Hello and welcome. In our previous lessons, we provided detailed technical information about DC motors, covering their structure, components, and how they function. Now, we will move on to the topic of servo motors, which will be a key component in many of the Arduino projects we plan to develop. In this three-part lesson, we will discuss the working principle of servo motors, the concept of torque in the motor, and the use of servo motors in remote-controlled projects. Let's start with the question, what is a servo motor? A servo motor is a type of DC motor that can rotate between 0 and 180 degrees with 1 degree precision. While most servo motors do not perform full rotations, there are models capable of rotating 360 degrees. Servo motors are commonly used in applications requiring precise angular positioning, such as steering mechanisms, pushing and pulling systems, and other tasks that demand high accuracy. At the bottom of the screen, we can see a sample robotic arm project that has been enhanced using servo motors. Every movement of this robotic arm, including the gripping mechanism, the upward and downward motions of the arm, or even its rotation around its axis, is entirely managed by servo motors. Additionally, with the help of potentiometers, we can control these servo motors effectively. This project can also be adapted for remote control operation, adding even more versatility. Now, let's take a closer, more technical look at the internal structure of the servo motor. Inside the servo motor, there is a DC motor connected to a series of gear mechanisms. The movement of these gears is further controlled by a potentiometer. The servo motor's output shaft can also be fitted with different types of attachments, depending on the requirements of your project. As the DC motor turns, the gears move along with it, causing the potentiometer to rotate as well. This rotation allows the potentiometer to measure the amount of movement precisely. Inside the DC motor, there is a motor driver and a control circuit, which are typically located at the bottom part of the servo motor. This means that when we use a servo motor, we don't need to connect any separate electronic device or motor driver module. This is because servo motors already have a built-in motor driver and control circuit. These components work together to compare the motor's current position with the desired position that we want to set. Based on this comparison, the motor driver and control circuit determine how the motor should operate and adjust its movement accordingly. The potentiometer, motor driver, and control circuit work in continuous interaction, comparing the motor's current position with the target position. This ensures that the motor moves precisely to align with the desired setting. The gears inside the servo motor play an important role by slowing down the rotation speed of the DC motor. This reduction in speed significantly increases the precision of the movements. Additionally, the gears amplify the motor's power, allowing us to achieve greater torque. This enhanced torque is crucial in applications where we need mechanisms for pushing, pulling, or directional control. Thanks to the gear system, the servo motor becomes highly effective for tasks that require strength and precision simultaneously. Now, let's talk about the torque of servo motors. Torque refers to the maximum load that the arm attached to the motor shaft can lift. Essentially, the torque of a servo motor is determined by the weight a 1 cm arm can lift when connected to the motor. For example, one of the most popular servo motors on the market, the Tower Pro SG90 mini servo motor, has a torque rating of 1.8 kilograms. This means that if you attach a 1 cm long arm to this servo motor, the arm can lift up to 1.8 kilograms. However, as the length of the arm increases, the lifting capacity decreases, as we know from the principles of physics. For instance, if your mechanism uses a 10 cm long arm, the lifting capacity is reduced to 1.8 kilograms divided by 10, which equals 180 grams. To better explain this concept, an illustration can be used to visualize the relationship between arm length and torque. If a servo motor has a torque of 20 kilograms at 1 centimeter and you increase the arm length to 2 centimeters, the lifting capacity decreases to 20 kilograms divided by 2, which equals 10 kilograms. If the arm length increases further to 3 centimeters, the lifting capacity drops to 20 kilograms divided by 3, resulting in approximately 6.6 kilograms. Now, in this part of the lesson, let's talk about the use of servo motors in remote-controlled projects. As mentioned earlier, hobby servo motors are most commonly used for steering in radio-controlled vehicles. In fact, servo motors were initially developed and used in RC projects worldwide. Here, we see a transmitter and receiver set used for remote control. This setup allows us to control servo motors without the need to write any code or use a microcontroller like Arduino. On the left, we have the transmitter, the remote control, and on the right, we have the receiver. This particular set supports 6 channels, meaning we can control up to 6 different motors using this remote control system. All remote control receiver modules have a 3-pin connection layout for each channel. Since servo motors also have a standard 3-pin configuration signal, power and ground, they can be directly connected to the receiver. Once connected and powered appropriately, the servo motors can be managed directly from the transmitter. There's no need to write any code or utilize additional components like Arduino boards. This simplicity makes these remote control sets highly suitable for various projects, such as robotic arms, model aircraft, or even industrial applications that require remote operation. In the example below, we see 3 different servo motors connected to the receiver and being controlled simultaneously. The power required for both the receiver and the servo motors is supplied by a LiPo battery. Furthermore, these remote control systems can be used to control not only servo motors but also DC motors. This versatility allows for the development of more complex projects where both types of motors are used in combination. In summary, remote control systems provide a practical and efficient way to manage servo motors, especially in projects where mobility and wireless control are essential. By eliminating the need for coding and additional microcontroller boards, these setups save time and effort while offering reliable control for your projects.